Welcome to my presentation. In this presentation, let us find the determinant of a 4 by 4 matrix. Let's say we have an example of this type. Matrix A has the following elements: 2, 6, 6, 2. Then that's in the first row. In the second row, we have 2, 7, 3, 6. And in the third row, we have 1, 5, 0, 1. And in the fourth row we have 3, 7, 0, 7. Let's say these are the elements we have in this matrix. By inspection of this matrix, we see that two of the elements in the third column are zeros. This will help us eliminate some of the work in expanding by using the third column, right? So if we were to go this direction, if we were to look at the first row, third column, we should be able to minimize certain amount of work. And the way to do that is as follows. To find the determinant of A, we can write this as follows. And the sign convention we are going to follow in here is as follows. The first row, first column, that sign would be positive. The next sign would be negative. This sign would be positive, and this sign would be negative. It always follows an alternative sign convention: positive, negative, positive, negative. And then coming down, the first row, third column, that is positive. The first row, third column is positive. Then that is negative. That is positive, and that is negative. So if we were to expand along the first row, third column, this is the way it's going to expand. So it's going to be positive 6, and the minors of that will be 2, 7, 6, and then 1, 5, 1. This is 5, 1, 5, 1, and then 3, 7, 7. And then negative 3 times the minor of that, and that is going to be 2, 6, 2, and then 1, 5, 1, and then 3, 7, 7. When we are looking at the second row, third column, then we're going to eliminate the second row and third column, like that. So therefore, when we eliminate that, so if we were to take second row, third column element, the minors of that element are going to be 2, 6, 2, 1, 5, 1, and then 3, 7, 7, like what I've shown you here. And then if we were to go down to the third row, third column, which is that, and if we were to delete the third row, third column, the elements of that are going to be positive 0 times 2, 6, 2, and then 2, 7, 6, and then 3, 7, 7. Let me write this thing down, and I'll show you how easy it is to just disregard this. And then in the fourth row, third column, which is this one, the elements of that would be, I'm going to write here, negative 0 times, the minor of that is going to be 2, 6, 2, 2, 7, 6, and then 1, 5, 1, isn't it? So as you can see, if we have 0 multiplied to that expansion, that is going to go to 0. 0 multiplied to that expansion, that is going to go to 0. Therefore, if we were to just look at the first two parts, then we should be, and expand them, that we should be able to find the determinant of the matrix A. So let's do that. So this is going to be equal to 6 times, and if we were to expand along the first row, which is that, it is going to be 2, the minor of that, 2, the minor of that will be 5177, like that, minus 7 times the minor of that, which will be 1137, like that, and then plus 6 times the minor of that will be 1537. That is the first part of the determinant. And then the second part is negative 3 times. We're going to travel along the first row, and therefore this is the way we're going to expand that. 2, the minor of that will be 5177, and then minus 6 times the minor of that will be 1137, and then plus 2 times the minor of that would be 1537. Okay, and then plus 0, so we don't need to do any of that there. So therefore now we are ready to simplify this part. This is going to be 6 times 2 times, we're going to find the determinant of 5177, which is going to be, we're going to multiply the major diagonals and multiply the minor diagonals, take the product of that. That is going to be as follows. 7 times 5 is 35, minus 7 times 1 is 7, then minus 7 times, multiply the major diagonals in this here. 1 times 7 is 7, 3 times 1 is 3, then plus 6 times 1 times 7 is 7, minus 3 times 5 is 15. So we got that part. And in the second part we have minus 3 times 2 times 5 times 7 is 35, minus 7 times 1 is 7, and then minus 6 times 1 times 7 is 7, minus 3 times 1 is 3, plus 2 times 1 times 7 is 7, minus 3 times 5 is 15. So we got all the numbers down, and it is just a matter of simplifying this part here. This is 6 times 2 times 35 minus 7 is 28, minus 7 times 3 is 4, plus 6 times 7 minus 15 is minus 8, then minus 3 times 2 times 35 minus 7 is going to be 28, and then negative 6 times 7 minus 3 is 4, and then we have 2 times 7 minus 15 is negative 8, close brackets. Now we'll simplify this some more. This is going to be 6 times 2 times 28 is 56, minus 7 times 4 is 28, minus 6 times 8 is 48, minus 3 times 2 times 28 is 56, minus 6 times 4 is 24, and then minus 16. We can simplify this some more, and then when we do that, this is what we're going to come up with. This is going to be 6 times 56 minus 28 minus 48 is going to leave us with minus 20, minus 3 times 56 minus 24 minus 16 is going to leave us with 16. Therefore, when we simplify this, 6 times 20, 6 times negative 20 is negative 120, minus 3 times 16 is negative 48. Therefore, when we combine these two, this is going to be equal to the the determinant of matrix A is going to be equal to negative 168. That is where we want to leave it. This is our answer. Okay, so this is the way we can find the determinant of a 4 by 4 matrix, and we can expand it to any size, and it is a matter of looking at the given matrix and looking at the path of least resistance. The path of least resistance, I mean that if there are zeros along a row or zeros along a column, we can travel along that row or that column and then make it a little bit more easier, because 0 multiplied by the expansion of those minor matrix will go to 0. Therefore we can eliminate that work and then just work with the numbers we have and be able to arrive at the determinant of a big size matrix like this in this manner. In my next presentation, I will show you an easier way to solve a 3 by 3 matrix by which will be a lot faster and easier to remember when compared to the method we just reviewed. In my next presentation, we shall look at that.